Good morning. So in this session, we are going to discuss about the brittleness of some crystal structures and ductility of some crystal structures in perspective of slip systems. So here, brittleness of BCC, HCP and ductility of FCC. The body-centered cubic and hexagonal close-packed structured materials are generally brittle in nature, and FCC structured materials are ductile in nature. Why? Okay. Now, before that, we know that what are ductile materials and brittle materials. So, when subjected to external loading or when the materials get stressed, they are capable of undergoing large amount of plastic deformation before a rupture or before fracture. So, the materials which are capable of undergoing extensive plastic deformation before rupture are called ductile materials. And on the other hand, the material which may break up abruptly or immediately with very little or no plastic deformation, such materials are called brittle materials. Okay, now if you look at the crystalline materials, we discussed about the two different type of plastic deformation, two mechanisms which is responsible for plastic deformation, slip and tuning. So uh, mm, among these two mechanisms, the dominant mode of plastic deformation mechanism is slip. Okay, and the deformation by slip, which depend upon the available number of slip systems within the crystal. And you may please note that the slip, when the material is subjected to shear loading, the slip occurs easily on planes and directions of maximum atomic density. So that's a very important point. Okay, when the material is subjected to external loading, I say shear loading, and if it is undergoing a plastic deformation, yeah, if it is undergoing plastic deformation by slip, and you may please note that the slip is occur easily on planes and directions having maximum atomic density or where the atoms are tightly packed. It is through the planes and this direction the slip generally occur. And such planes and directions constitute easy slip systems. They are generally referred to as easy slip system or common slip systems. Okay, now in the case of FCC crystal systems or FCC crystals, the 111 planes and 110 directions have the maximum atomic density. So the 110 direction ഇതിന് രണ്ട് angle brackets ഇവിടെ കൊടുത്തിട്ടുണ്ട്. So there is only one bracket, that two brackets is a mistake. Okay, so if you look at the FCC crystal structured materials, the what is that 111 shows planes, it's a family of planes അല്ലേ? So അപ്പോൾ ഇവിടെ എത്ര planes possible ആണ്? It represents a family of planes means 111 in square 111, then 1 bar 1, maybe 1 bar 1 1 bar, maybe 1 bar 1 1, isn't it? 4 plus 1 1 1 1 1 0 direction means 1 1 0 1 0 1 0 1 1, then 1 1 bar 0, 1 0 1 bar 0 1 bar 1. So likewise, if you calculate, there are 12 easy slip systems are available in FCC crystals. Through these planes have maximum atomic density are these directions and these planes, which means when that material, that FCC structured material subjected to an external shear loading through these planes and directions, the slip may occur. Okay, so it is so when, as I told you, when this material is subjected to external shear loading, it is possible to have at least one slip system among these 12 slip systems, at least one slip system oriented in a favorable position for the slip to take place, and therefore the slip and thereby plastic deformation initiated easily in FCC crystals. So therefore I can say the materials having FCC structure are therefore ductile in nature. They can easily get deformed into plastic deformation. Okay. And now if I look at the BCC crystal structure materials, what would be the whether it is ductile in nature or brittle in nature? I will say it is in between ductility and brittleness. It is having the property. If you look at the BCC crystal structure, it also having 12 VC slip systems available. So with the 110 planes and 111 directions, 1110 represents the family and 111 direction represent the family of directions. And now you know how what are the different planes possible and different directions. If you can add it, you can get 12 slips, easy slip systems are available in basic crystals. അപ്പോൾ നിങ്ങൾ നോക്കുമ്പം ബി സി സിയിലും 12 വി സി സ്ലിപ്പ് സിസ്റ്റംസ് ഉണ്ട്, എഫ് സി സിയിലും 12 വി സി സ്ലിപ്പ് സിസ്റ്റംസ് ഉണ്ട്. പിന്നെ വൈ എന്തുകൊണ്ടാണ് ഇരിക്കാം ഞാൻ പറഞ്ഞത് ബി സി സിയുടെ നേച്ചർ എന്ന് പറഞ്ഞു കഴിഞ്ഞാൽ ഏകദേശം ബ്രിട്ടിൽനെസ്സിനും ഡക്റ്റിൽനെസ്സിനും ഇടയ്ക്കാണ്, അല്ലെങ്കിൽ അത്രത്തോളം ഡക്റ്റൈൽ അല്ല എഫ് സി സിയെ കമ്പയർ ചെയ്യുമ്പം എന്ന് പറയാൻ എന്താവും കാരണം? ദ ഓൺലി റീസൺ കുഡ് ബി in the case of BCC structured material, the BCC have lesser atomic density compared to the 111 planes of FCC. So here you can see 110 planes of BCC. Okay, the 110 planes of BCC have lesser atomic density compared with 111 planes of FCC crystals. 111 planes of FCC crystals. Therefore, the stress required to cause the displacement will be more. Okay, therefore the stress required to cause atomic displacement will be more in BCC crystals, which means you need more amount of stress to initiate a deformation or displacement in BCC crystals. So compare with FCC crystal, the BCC materials are less plastic or less ductile compared to FCC, more prone towards the BC brittleness. And if I look at, okay, lesser atomic density, that is the point. However, if you look at the HCP crystal structured materials, what would be the nature? They are generally brittle in nature. Why? Because if you look at the HCP crystals, the planes having atomic density are um, 0001, the basal plane, and the direction 1120, which means only three common slip systems are available in HCP. So as there is only less slip systems, the HCP materials are normally brittle. So ഇവിടെ സ്ലിപ്പ് നടത്താനുള്ള സാധ്യത വളരെ കുറവാണ്, and slip and thereby plastic deformation. And in addition to the common or easy slip systems, there are slip systems called less common slip systems. They are available in these materials which initiate slip and thereby plastic deformation. Okay. Um, and but these less common slip systems, they are activated only at higher stresses. You need to apply a higher loading, then only these slip systems get activated, and only at certain temperatures it gets activated. Okay. Okay, thank you.